This video is about math induction for divisible questions. 11. 9 to the nth power minus 1 is divisible by 8. We will use the CAP method. Check, assume, prove. Check it's true for n equals 1 because here all positive integers n. 9 to the first power minus 1 equals 8. So it's true for n equals 1. Assume it's true for n equals k, which means 9 to the kth power minus 1 is divisible by 8. We want to prove it's true for n equals k plus 1. So we want to prove for 9 to the k plus 1th power minus 1 is divisible by 8. Now we get started from left side. 9 to the k plus 1th power minus 1 equals. In your mind, remember we want to create 9 to the kth power minus 1. So we will make 9 to the k plus 1th power into 9 to the kth power times 9 to the first power minus 1. 9 times 9 to the kth power minus 1. Then we go to thinking part. Do not write this on your paper. We want to get 9 to the kth power minus 1. Now we have this 9 times 9 to the kth power. As long as you get 9 times 9 to the kth power minus 9, we can get this 9 to the kth power minus 1. So we will do 9 times 9 to the kth power minus 9. Then you have to plus 9. Then here minus 1. So that we can take this 9 out. We create 9 to the kth power minus 1. Then for these two, 9 minus 1 is 8. Because 9 to the kth power minus 1 and 8 both are divisible by 8. The first one is based on our assumption. The second one, 8 can be divided by 8. So 9 to the k plus 1th power minus 1 is divisible by 8. Therefore, 9 to the nth power minus 1 is divisible by 8 for n is positive integers. Let's go to 12. We want to prove 6 to the nth power plus 4 is divisible by 5. Check it's true for n equals 1. 6 to the first power plus 4 equals 10. 10 is divisible by 5. Second step, assume it's true for n equals k, which means 6 to the kth power plus 4 is divisible by 5. We want to prove it's true for n equals k plus 1. We want to prove 6 to the k plus 1th power plus 4 is divisible by 5. So we get started from 6 to the k plus 1th power plus 4 equals. We need to separate this 6 to the k plus 1th power equals 6 to the k's power times 6 to the first power. So we write down 6 to the k's power times 6 plus 4. Organize 6 times 6 to the k's power plus 4. You have to create this. This is your thinking part. Do not write this on your paper. We want to create 6 to the k's power plus 4. We are given 6 times 6 to the k's power. Let's do the distributive property. 6 times 6 to the k's power plus 24. We need to add 24 to create 6 to the k's power plus 4 equals 6 times 6 to the k's power plus 24. Then you have to minus 24, then plus 4. We will take this 6 out so that we can create 6 to the k's power plus 4. Combine like terms, minus 20. Because 6 to the k's power plus 4 and 20 are both divisible by 5. So 6 to the k plus 1th power plus 4 is divisible by 5. Therefore, 6 to the nth power plus 4 is divisible by 5 for n is positive integers. 2 to the power of 3n minus 1 is divisible by 7. Check. It's true for n equals 1. 2 to the 3rd power minus 1 equals 7. So it's true. Assume it's true for n equals k, which means 2 to the power of 3k minus 1 is divisible by 7. Then we need to prove it's true for n equals k plus 1. 2 to the power of 3 times k plus 1 minus 1 is divisible by 7. Let's get started from left side. 2 to the power of 3 times k plus 1 minus 1 equals distributive property 2 to the power of 3k plus 3 minus 1. We want to create this 2 to the 3k's power minus 1. So we separate this 2 to the power of 3k times 2 to the 3rd power minus 1. Simplify. 2 to the 3rd power is 8. 8 times 2 to the 3k's power minus 1. This is your thinking part. We want to create 2 to the power of 3k minus 1. On these expressions, we got 8. So we will put the 8 before that, distributive property. 8 times 2 to the power of 3k minus 8. In other words, we need to subtract 8 to create 2 to the power of 3k minus 1 equals 8 times 2 to the power of 3k minus 8 plus 8, then minus 1. Take 8 out. We got 2 to the 3kth power minus 1 plus 7. Because 2 to the 3k's power minus 1 and 7 are divisible by 7. So 2 to the power of 3 times k plus 1 minus 1 is divisible by 7. Therefore, 2 to the 3nth power minus 1 is divisible by 7 for n is a positive integers. Let's go to 14. We want to prove for 5 to the nth power minus 2 to the nth power is divisible by 3. Check. It's true for n equals 1. 5 to the first power minus 2 to the first power equals 3. It's true. Assume it's true for n equals k, which means 5 to the kth power minus 2 to the kth power is divisible by 3. We want to prove it's true for n equals k plus 1, which is 5 to the k plus 1th power minus 2 to the k plus 1th power is divisible by 3. So we got 5 to the power of k plus 1 minus 2 to the power of k plus 1. In your mind, remember, we want to create this. So first step, definitely we need to separate 5 to the power of k plus 1 into 5 to the kth power times 5 to the first power minus 2 to the kth power times 2. Simplify 5 times 5 to the kth power minus 2 times 2 to the kth power. This is our thinking part. We want to create 5 to the kth power minus 2 to the kth power. In our expressions, we got this 5 before 5 to the kth power. So we will do 5 here, do the distributive property, equals 5 times 5 to the kth power minus 5 times 2 to the kth power. In other words, we need to subtract 5 times 2 to the kth power to create 5 to the kth power minus 2 to the kth power. Let's do it. 5 times 5 to the kth power minus 5 times 2 to the kth power. Then you have to add 5 times 2 to the kth power. This one bring down minus 2 times 2 to the kth power. Take this 5 out to create 5 to the kth power minus 2 to the kth power. Combine like terms, plus 3 times 2 to the kth power. Because 5 to the kth power minus 2 to the kth power and this 3 are divisible by 3. So 5 to the power of k plus 1 minus 2 to the power of k plus 1 is divisible by 3. Therefore, 5 to the nth power minus 2 to the nth power is divisible by 3 for n is all positive integers.